Alright, so today for assignment 1 we are starting on factoring. So a few things that we need to discuss about factoring. If we look at your worksheet today, number 1, we are dealing with polynomials. So what is a polynomial? That's a review from Algebra 1. Poly means many. And then we can have a monomial, which means one. And we're talking about terms here. I'll talk about terms in a moment. We could have bi, which means two. So you'd have a binomial. We could have tri, which means three. So we could have a trinomial. Or anything above that we call just a polynomial. A polynomial of 4 terms, 5 terms, 6 terms, so on and so forth. Well, now then, what is a term? A term is the how many monomials are in the polynomial. So for example, number 1, this is considered a monomial because we have a number times variables. This is then considered a monomial because again we have a number times variables. And so in this problem, this is actually a binomial because we have 2 terms. Okay, terms are separated by addition. Now you might be thinking, wait a minute, that has subtraction there. Well, actually, I could rewrite that as negative 3v squared plus a negative 27v. So again, there's my 2 terms separated by addition. Well, next we want to factor this. So what does it mean to factor? Well, it means to factor that if, for example, let's say we have 12. I can factor 12 into 4 times 3. But I could also break 4 down again into 2 times 2. Okay, or maybe I could have broke 12 into 6 times 2 and then broke the 6 into 2 times 3. But I'm breaking that down using multiplication. I am rewriting the 12 as a multiplication problem, 4 times 3. So therefore, that process right there is factoring, breaking something down using multiplication. But the pieces here, like the 4 or the 3 or the 2 over here, those are then factors of 12. So if we want to factor negative 3v squared plus negative 27v, what we're going to want to do is we first want to break down each term. So I would have negative 1 times 3 times v times v. Now my second term is negative 1 times, now 27 can be 9 times 3, but 9 can be broken down into 3 times 3. So I have 3 times 3 times 3 is 27, and there's still a v there, times v. So to find the GCF, the greatest common factor, GCF is greatest common factor. So to find the greatest common factor, I go through and look at these 2 groups and say, well, what's the same? I got a negative 1 in both groups. I've got a 3 in both groups. I've got a v in both groups. And so my greatest common factor are those things multiplied together. Negative 1 times 3 times v. Negative 3v. Because I'm taking a negative 3v out of both groups. Then, in parentheses, what's left behind? I still have a v and a 3 times 3. So that means I have v plus 9 left in parentheses. So I've taken my original binomial, which was negative 3v squared minus 27v, and I have pulled a negative 3v out of both of those terms, which then that negative 3v goes out in front, and I'm left with a v plus 9 behind. All right, let's try another one. So I'm not going to write all that work down every time. And you will be getting used to doing this as well without showing as much work. So if we're looking at this binomial, we have two terms. We first look at the numbers called the coefficients. We have a 2 and we have a 4. They have a common factor of 2, so we bring that out in front. Now we look at the variables. We have an x squared and we have an x, so we can factor out an x. What's left behind in the first term? An x. What's left behind in the second term? A 2. You can always check your work by distributing. If we take 2x times x, we get 2x squared. If I take 2x times 2, I get 4x. I know it works out because that's exactly what we started with. So there's our answer. Let's try one more. Number 5. Looking at number 5, this brings us to a specific rule that I like to point out to students. If we have any polynomial, in this case we have a binomial because it has two terms, and if the leading coefficient, which means the number out in front, if that number is negative, then we have to factor out a negative. So I know in this case I'm going to factor out a -1, at least a -1, which in fact, if I look at 3 and 21, I know they have a common factor of 3. So I'm pulling out a -3 from that binomial. Looking at the variables, I can factor out an a from that binomial. So now I think about what am I going to put in here as my remainder binomial? What's left behind in there? Well, -3a times what gives me -3a squared? Well, that would be a. There's an a left behind. And then -3a times what gives me positive 21a? Well, that must be a -7, because -3 times -7 gives us the positive 21. Looking at the back side of your worksheet, number 11, we now have 4 terms. So we're going to factor this using something called grouping. The first thing you want to do is look to see if there is a GCF, or greatest common factor, that you can take out of all 4 terms. And in this case, no. If we get close, you can take a 3 out of 3 of the terms, or you can take a 2 out of 3 of the terms, but there's nothing you can take out of all 4 terms. So we can't factor a GCF, but to do grouping, we literally group the first 2 terms together and then the second 2 terms together. You're always going to want a plus sign between your 2 groups. And I'll show you what happens if you don't. I'll show you how to take care of that. But this problem, we have a plus sign there already, so we're happy. So now that we have it grouped, we look at the first group. Just pay attention to this first group for now and factor it. So between 12 and 9, we can factor out a 3. And then we have x cubed and x squared, so I can factor out an x squared. I can factor out 2 x's. So 3x squared times what gives me 12x cubed? That is 4x. And then 3x squared times what gives me -9x squared? That is -3. Looking at the second group, 8x and -6, looks like I can factor out a 2. And I'm left with 4x minus 3. So now that I have these factored, I'm not quite done. I want to look at this as if this is one big binomial. Okay, we've got to really focus at the big picture here. We got 2 things added together. And in those 2 things, I have this common factor of 4x minus 3. So I want to take that common factor and pull it out in front. I'm going to bring it out in front of everything, giving me 4x minus 3 times then what's left behind. Well, what is left behind is the 3x squared plus 2. That gives us our final answer. We'll do one more together. If we take a look at number 13 on your worksheet, first thing we want to do is we want to look for any GCF we might have, and in this case 2 can be factored out of all 4 of those terms. And I'm going to use a bracket rather than a parenthesis here. It means the same thing, but it looks different, so it helps us organize our work. So I now have 5m cubed minus 15m squared minus 3m plus 9. So now that I have the 2 factored out, that 2 is just going to come along for the ride, okay? Because it's going to be 2 times all of this stuff, and right now I want to work with all of that stuff. So looking at those 4 terms in the brackets, I want to group because I have 4 of them. So I group the first 2 together. Now the second group, I can't just go ahead and put a parenthesis there around the 3m because I have minus 3m. So I need to change that to plus negative 3m. And then when I group it, that negative is going to come into that second group. So now I have my first group plus my second group. And my second group is negative 3m plus 9. Alright, we work it just like the previous problem, except that 2 comes along for the ride outside. So looking at the first group, I can factor out a 5m squared. Inside my parentheses, I'm left with m minus 3. Now in the second group, I got that plus sign from above, but now my leading coefficient is negative. So I need to factor out a negative number. And between 3 and 9, they have a common factor of 3. So I'm going to factor out a negative 3, which leaves me with a positive m, but now a negative 3 is left inside. Again, that's because negative 3 times negative 3 gives me that positive 9 that I started with. I want to look at the 2 large groups. And looking at those 2 large groups, just like we did before, they have a common factor of m minus 3. So I bring that out in front. Again, that 2 is still coming along for the ride, but now it's 2 times m minus 3 times what's left over, which is that 5m squared minus 3. 5m squared minus 3. That then gives us our final answer.